Hey guys, power's back on in the building and Wi-Fi is up and running. It's actually been on, came back on about 15 minutes after the buses left. So you guys lucked out. But in a way you kind of didn't luck out because we still have to do our e-learning lesson. And really what we have here is one lesson that was to take about 2.5 days to do that we're going to do over the course of today and tomorrow and Wednesday. And so we're going to get started. I've got a timer set here for about 30 minutes or so, because that's probably about all I want to do with you guys today. And we'll just finish up the other stuff. So let me go ahead and get started by sharing our lesson plans for this week. You'll notice if you looked at it, it just says properties of exponents, properties of exponents, properties of exponents. I don't want you to forget that Friday, after your test on Friday, you started the 10.1 homework. Now, the 10.1 homework did not need a work paper. It was just exponent review. Some of it might have been new, and I'm actually going to cover it, some of that in our notes today. The rest of these will need a work paper. Now, you were not here to get the work paper, but actually what you're going to get from me tomorrow is a packet. Okay, and the packet tells you exactly which problems we're doing from each section, 10.1 through 10.4. I threw a couple extra 10.1 problems in on your homework since it was your kind of your chapter 10 opener. But you will need to fill out the packet. The big ideas homework is going to be worth about 40 points. The packet itself is going to be worth another 40 points. So if you don't do the packet, you're failing the assignment. You need to make sure you do the packet. And so feel free to do as much of the homework as you want to tonight. And then when you get the packet tomorrow, you'll have to copy down your answers and any work that you had for your answers onto that packet. You're not doing your own work paper on your own piece of paper. You're all getting a paper copy of the packet from me tomorrow. Okay, you're supposed to get it today, but obviously that's not going to happen. So, and I'm not going to do a digital copy because I want it to be on paper. So you guys will have that paper copy. I've already got them printed. We're going to have a quiz on Thursday. We're actually going to do our quiz during ST and then do our exponents murder mystery during class. That was supposed to be the review. And I just put it there because I didn't know how long this was going to take us to do. Right. So if we have 3 days to get it done, quiz on Thursday, and then we're going to start a similar packet, but it's going to be about half the size that we're going to do with scientific notation that starts on Friday. And this is also that we can squeeze our last 2 chapters in before the end of the school year. So you guys still can take NWEA and then be done, right? That whole last week of school, you guys would be done, and this will work out very nicely for us. Okay, so let me go ahead and get started and share the notes here. And I'm going to turn my timer on so I don't go over 30 minutes. I guess I didn't hit it the first time. So there we go. Okay. So we're talking about exponents this chapter. Chapter 10 is all about exponents. Then we move into scientific notation, which uses exponents. So we're going to talk about properties of exponents today. So we have to know what is an exponent and what does it do? So first of all, we have 3 vocab words. We have a power. A power is a product of repeated factors. So just like multiplication works when you have repeated addition, exponents work when you have repeated multiplication. That's what factors are. Factors are numbers you're multiplying together. So if I did 5 times 5 times 5, for example, I could do 5 to the 3rd power. Or in this example, 1/2 times 1/2 times 1/2 times 1/2 times 1/2 is 1/2 to the 5th power. The base, in that case 1/2, is your common factor, the factor that keeps repeating, and the exponent indicates the number of times the base is repeated as a factor. Okay, so in this example, you can see the base is 1/2. The exponent is 5 because it repeats 5 times. And then we call that whole thing a power. The whole thing, the base and the exponent included, is called a power. Okay. Notice how they used parentheses there. Anytime and we'll talk about this in more detail later as well, anytime your factor or your base is a fraction or a negative number, you have to use parentheses. Okay, you can't just put 1/2 like this and put to the 5th power, because technically that means you're just raising the top number to the 5th power, and that's not the case here. We want to raise both numbers, so we include it in parentheses to show that not just the one, but the entire fraction is being raised. Okay, so let's go ahead and fill out this chart here. Again, we have negative bases, so I want you to look to see, how did they use parentheses here? They use parentheses around the 3 and the negative sign, because if you just type in -3 like that into your calculator is going to say, sorry, this does not go in the right spot. I'm just going to put it up here. If you put -3 squared in your calculator is going to say the answer to that is -9, and that is true, because exponents take place before multiplication does. And the way that your calculator reads this, and the way that it's actually read math, is that negative sign is a -1 being multiplied to the 3. So it was going to do 3 squared first and then make your answer negative. Much in the same way, where if I was squaring 9, that means square 9, then make your answer negative. This means square 3 and then make your answer negative. But we know that whenever we square a number, we're supposed to get a positive answer. And that's because this should be written in parentheses like they wrote it here. -3 times -3, we know, of course, is just 9. Okay. So we got to make sure we're using parentheses. I'll put that back there. Okay, so -3 to the 3rd power, what would that be? -3 times -3 times -3. Okay, that's what the repeated multiplication would be. And then you have 3 negatives, so we're going to have a negative answer. And 3 times 3 times 3 is 27. So -27 would be our value for that. Okay, -3 to the 4th power is going to be -3 to the 3rd power, and then add another -3 in there. So I'm just going to copy and paste. 3 times 3 times 3 times 3, 9 times 9 is 81. This time you have 4 negatives, and that's going to make your answer positive, because 4 negatives will make a positive because it's an even amount. In fact, what you're going to see is we're going to alternate back and forth between positive values and negative values. Negative, negative, negative. And the reason we're alternating back and forth is because our exponent's going from odd to even, and odd to even. -3 to the 5th power. See, you need to add another -3 in there. Okay, that's going to be 81 times 3, basically, and then make your whole answer negative because you have 5 negatives. 81 times 3 is 243. So that's going to be -243. -3 to the 6th power. I think you're probably catching on to the pattern by now. Is going to be 6 -3s, which means I'm going to do 243 times one more 3 to get 729. This time, those 6 negatives will make my answer positive, 729. And finally, -3 to the 7th power means I'm going to have 7 -3s. So 729 times 3 is 2,187. And because there's 7 negatives, that will be a -2,187. So that pattern keeps alternating, and that happens anytime you are raising a negative number to a power and you keep increasing that power, it's going to alternate back and forth between positive and negative. Now, if I was raising a positive number like 6 squared, 6 to the 3rd, 6 to the 4th, 6 to the 5th, I'm always going to get positive because my base itself is positive. But if your base is negative, it's not always negative. It alternates back and forth like we see here between positive and negative. So use parentheses to write powers with negative bases. Otherwise, it's wrong, right? If you just write like I did up here, if you write -3 squared, that equals -9. So what actually you're writing here isn't squaring -3, you're just squaring 3 and making your answer negative. So you got to make sure you can put it in parentheses, okay? Okay, next one, write each product using exponents. So this is easy enough. -7 is being repeated 3 times. Please don't write -7 to the 3rd power. We just said that's not how you write it. If your base is negative, then you have to write that base using parentheses. So write -7 to the 3rd power using parentheses around the -7. Okay, here we have pi times pi times pi times r times r. So we could say pi to the 3rd power times r to the 2nd power. This time I don't need to use parentheses because none of my bases were negatives. See, we have 1/4 times 1/4 times 1/4 times 1/4 times 1/4. I think I said that the right amount of times. This time we have a fraction. make sure you use parentheses also when you're working with fraction bases. Example D, 0.3 is being repeated 4 times, so 0.3 to the 4th, and then x is being repeated twice, multiplication, so x squared. Okay. All right, so that's really a review of that section 10.1. So again, powers with negative bases. If your exponent is even, your answer is going to be positive. Like -3 to the 6th was a positive answer, right? If you have a negative base with an odd exponent, your answer is going to be negative. Like -3 to the 7th was negative. And that's because you have 6 negative signs here, so the answer is positive. But here you have 7 negative signs, which is odd. I'm sorry, 6 is positive because that's even. You have an even number of negative signs. And then because 7 is odd, you're going to have one negative that can't partner up with the rest. So your answer is going to be negative here. Okay. All right, evaluate each expression. For the first one, -2 to the 4th power, they're asking us to evaluate it. That means to solve it. Don't just write it out, but actually solve it and get an answer. So that's going to be 2 times 2 times 2 times 2. And with the 4 negatives, that'll make a positive answer. So 2 times 2 times 2 times 2 is 16. So this will be positive 16. For the second example, they took away the negatives, the parentheses. They didn't take away the negative, took away the parentheses. So what this is actually going to be is 2 times 2 times 2 times 2, then make the whole thing negative. So this is going to be -16. So a way to think about this is pretend that the parentheses that we have here act as a magnifying glass. The exponents can't see the negative sign unless the parentheses are there. So if the parentheses are there, the exponent will repeat that negative sign 4 times, which gives you a positive 16. Here, the parentheses are not there, no magnifying glass. The exponent does not see the negative sign, so it's going to repeat just the 2, and that 1 negative there just drops down and makes your whole answer negative. So again, think of the parentheses as negatives. Now, what I don't want you to hear me say is that every time there's parentheses, your answer is going to be positive. That is not true. Here, the exponent sees the parentheses, or exponent sees the negative because of the parentheses, but it's still going to repeat the negative 5 times. That's an odd amount, so it's going to be -32. For example D, the answer is also -32, but for 2 different reasons. In example C, we had 5 negative signs. Yeah, that makes a negative answer. Here, for example D, we only had 1 negative sign because the exponent never repeated the negative. However, since 1 is still an odd number, the answer is negative there. So they're both -32, but for 2 different reasons. Okay, now we can use some order of operations to evaluate these expressions. Of course, exponents happens at the very beginning after parentheses. Please excuse my dear Aunt Sally. So this is going to be 3 plus 2, and then 3 to the 4th power. 3 times 3 times 3 times 3 is 81. After parentheses and exponents comes multiplying and dividing from left to right. And I see some multiplying we have to do here. 2 times 81 is 162. Obviously, if you did 3 plus 2 first to get 5 times 81, you're going to get a completely different answer that's wrong. So make sure you're following order of operations, and then your answer is going to be 165 for this one. For example, B, -1/6 to the 3rd power. That's an odd number of negative signs. So no, my answer is going to be negative. When you're raising a fraction, remember, you're really doing 1/6 times 1/6 times 1/6. So think about that you're just cubing the top number and you're cubing the bottom number. Okay, that's really what you're doing. So of course, we're going to get a 1 on top, and then 6 times 6 times 6 is 216. So this is going to be -1 over 216. So when you're raising a fraction to a power, you have to square the top and bottom number. So they had to use parentheses here, not only because it was a fraction, but because it was a negative fraction as well. So keep in mind that those 3 negatives that you're going to have are still going to make a negative answer. Example C, the absolute value of -3 divided by 27. Okay, well, -3 divided by 27 can be written like this. We can actually write that as a fraction. And then 3 divided by 27 can be reduced to 1/9. But the absolute value symbols are going to make that answer positive. So this is going to be positive 1/9. Example D. Exponents first. 5 times 5 times 5 times 5 is the same as 25 times 25. And we know from our perfect squares that should give us 625. So 9 minus 625 times 0.5. My next step would be to do the multiplication, not the subtraction. So 625 times 0.5, you can use a calculator for this. I'm not saying you can't use your calculator, just saying be careful when you type your exponents in. That's going to give us 312.5. And we're supposed to subtract that away from 9. So 9 minus 312.5 is negative 303.5. Okay, negative 303.5. Sorry about that. Share my screen again here. All right. In sphering, I did not know this is something you can do, but this looks absolutely fun. In sphering, a person is secured inside a small hollow sphere that is surrounded by a larger sphere. The space between the spheres is inflated with air. What is the volume of the inflated space? Write your answer in terms of pi. Okay, so remember our volume formula for spheres is 4/3 pi r cubed. That's why they're putting it in this chapter, because you have to cube that radius. All right, that's our volume formula for spheres. The inner sphere, the volume would be, if you use the 2 meters we have here for the radius, that's the diameter, then the radius would be 1. And so that would be 4/3 pi times 1 cubed. Okay. Now our radius in the outer sphere, which is just full of air, the person I don't think actually goes in the outer sphere. The diameter here is 3. So the radius is going to be 1.5. So 4/3 times pi, and we'll call it 3/2 r cubed. Okay. It says, what is the volume of the inflated sphere? Well, the volume of the inflated sphere is going to be this part right here. Okay, minus the part in the middle. It says there's a small hollow sphere surrounded by a larger sphere. It wants to know the space between the spheres that's inflated with air here. Okay, so what's what volume of that inflated space? So what we can do is we can subtract these 2 volumes. Okay, the inner sphere subtracted away from the outer sphere. So we're going to simplify this a little bit. Obviously, 1 times 1 times 1 is just still 1. So this is 4/3 pi. And for this one, we've got 4/3 pi, and then 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. So that's going to be 27/8. And then I'm supposed to multiply all this together. And fortunately for us, this is going to cancel. The 4 and the 8 can cancel to a 1 and a 2. The 3 and the 27 can cancel to a 1 and a 9. So this is now going to be 4/3 pi, and this is going to be 9/2 pi. And then I need a common denominator. My common denominator is going to be 6. So I can write this times by 2 to get 8/6 pi. This one, if I times by 3, is going to give me 27/6 pi. And then I can subtract 27/6 minus 8/6. And that's going to give us 19/6 pi. Now, before you try to calculate that out, or even if you were thinking, what if I just did this with decimals? It wanted us to write our answer in terms of pi. So we don't need to do anything other than write our answer as 19/6 pi. Or if you wanted to write it as 3 1/6 pi, you could do that as well. All right, let's get into some other properties. So that was kind of an exponent review, using different exponents. Now let's get into using properties of exponents, okay? So the first property we're going to look at is what happens if I'm multiplying 2 exponents, 2 powers together, and they have the same base. So you notice all these powers that I'm multiplying together have the same base, the 2s, the -3s, the x's, and the 10s, okay? So I'm going to first write this off using repeated multiplication. So 2 squared means 2 times 2 times 2 to the 4th. 2 times 2 times 2 times 2. How could I write that using exponents? Well, the times sign that I use with the x is still a times sign. So really what I have here is 6 2's that are being multiplied together. I could write this as 2 to the 6th power. Okay. For the next one, I've got -3. Here, let's write this over here. -3 times -3 times -3. That's -3 to the 3rd. And then that's getting multiplied by, copy and paste. Oops, don't want that black line. There you go. Copy and paste, -3 times -3 times -3 again. Okay. And so what I have there is really, again, just 6 -3's. If I use parentheses to write it, I could just write that's -3 to the 6th power. What about the next one? I've got x times x times x times x times x times x multiplied by another x. Well, that's now 7 x's. And then 10 times 10 times 10 times 10 times 10 is getting multiplied by 10 to the 2nd power. And that's now just 7 10s. And so here's the first power property. To multiply powers with the same base, all you have to do is add their exponents. Now it's important here that they have the same base. I can't do 2 squared times 3 to the 3rd and say that's going to be 6 to the 5th. It does not work that way. Okay, so it has to be the same base. That does not work. So here we have 2 plus 4 equals 6. 3 plus 3 equals 6. 6 plus 1 equals 7. And 5 plus 2 equals 7. All you have to do is add the exponents. Okay, now on the flip side to that, we have the quotient property. And if you're good at patterns, you're probably going to figure out very quickly what we're going to do here. 2 to the 4th divided by 2 squared. So that's how I would write it out using repeated multiplication. Well, this 2 on the bottom is going to cancel out with this one here, and this one's going to cancel out with that one. So what I really just have is 2 2's on top, and that's 2 squared. Okay. For the next one, I've got y times y times y times y times y times y times y divided by y times y times y. These 3 y's on bottom are going to cancel out with 3 of them from the top. And so you're left with 4 on top, y to the 4th. And you can probably figure out the pattern here, right? 4 minus 2 is 2. 7 minus 3 is 4. All we have to do when we're dividing powers with the same base is subtract the exponents. Add the exponents if you're multiplying those powers, subtract the exponents if you're dividing those powers. Okay, here's more proof. 5 times 5 times 5 times 5 times 5 times 5, all divided by 5. Well, that 5 is going to cancel out with that 5. You're left with 5 5's on top, 5 to the 5th power. And that's what you'd get if you did 6 minus 1. And don't make me write out 10 A's, please. You have 10 A's on top, 9 A's on bottom. The 9 A's on bottom are going to cancel out with 9 of them from the top. That's going to leave you 1 A on top. And that's going to be A to the 1st power, or we could just say A, because a number to the 1st power is just itself. So again, to divide powers with the same base, subtract their exponents. They must have the same base in order for it to work. The next property we have is the power of a power property, and here's how this one works. X squared is all being raised to the 4th power, which means we have x squared times x squared times x squared times x squared. And I can even go another layer. I could break that down even more and say x times 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 x. How many x's would there be? Oh, yeah, there'd be 8 of them, right? So we could say this is x to the 8th power. In fact, our multiplication property says we just add those together. 2 plus 2 plus 2 plus 2 is 8. But even better than that, there's a shortcut. When you're raising a power to a power, all you have to do is multiply the two exponents together, not add them together. Notice how this is different from what we did up here. Here, I was multiplying two bases together. Here, I have one power, and I'm raising that power to another power. So I can use the multiplication rule. 5 to the first is just 5 to the first times 5 to the first times 5 to the first. 1 plus 1 plus 1 is 3. Or you could just say 5 to the third. Or you could say 5 to the first is just 5, and 5 to the third power is 5 to the third. 6 to the third times 6 to the third. It's going to repeat twice, right? Well, 3 plus 3 is 6. Here's a shortcut. 3 times 2 is also 6. Just multiply. And then last but not least, b to the 5th times b to the 5th times b to the 15th can be just 5 times 3 is 15. I think I said 15th. b to the 5th times b to the 5th times b to the 5th is b to the 15th. Okay, b to the 5th times b to the 5th times b to the 5th. Because if I broke that down, I'd have 15 b's, all being multiplied together. Okay, and then the last power we're going to talk about, probably all the ones we have time for today, and then we'll review a little bit, is the power of a product property. Okay, and the power of a product property says basically this: distribute the power to the bases inside. Here you'll notice we have different bases, so this is a bit of an issue, but you can distribute the power on the outside to the bases on the inside. Okay, so this would be the same as 2 to the third power times 3 to the third power. That's actually the answer that's supposed to go right here. Okay, because this would be 2, well, let's write it out like this. It'd be 2 times 3 times 2 times 3 times 2 times 3, and I can rearrange the order, because it's multiplication, to look like this. And now you can see that we can just say that's 2 to the third power times 3 to the third power. Okay. So this one here is going to be 2 to the second power. I'm not going to write it all out, times 5 to the second power. Notice it's not asking us to evaluate it. It's asking us to write it as a power. If it was asking me to evaluate it, I'd want to know what 2 squared and 5 squared was, and then multiply them together. This next one, I can distribute the 4 to the 6th, the 4 to the a. So that would be 6 to the 4th times a to the 4th. And I can write that as, actually, I could probably, in this case, 6 to the 4th would be 36 times 36. That's 1,296. And I could just put a to the 4th next to it. So this time I'll go ahead and evaluate that portion of it. And then finally, 3x all squared, using parentheses, all squared means I'm going to square the 3 and I'm going to square the x. That's going to give me 3 squared times x squared. 3 squared we know is 9, so 9x squared. The power of a power property says to find a power of a product, find the power of each factor and multiply. So 3 times 2 to the 5th means I'm going to distribute the 3 to the 5th and 2 to the 5th. Okay, or I can do the same thing if I'm just using variables as well. Okay, let's do some review problems together, and then you guys can get started on probably more than just your 10.2 homework tonight. You can even dip in the 10.3. Simplify each expression. Write your answer as a power. Okay, the product of a power rule, I think that's what it's called. Product of powers property. The product of powers property says that when I'm multiplying two powers together with the same base, I can just add the exponents. This is going to be 2 to the 9th power. Look how easy that is. Don't even have to evaluate it because it just wants me to write it as a power. Here I'm multiplying -1/2 to the 3rd times -1/2 to the 6th. That's going to give me -1/2 to the 3 plus 6 power, which is the 9th power. Z to the first power, that's implied. We don't have to write the 1 if you don't want to, but it is going to add 1 to the 12. So when I add the 1 and the 12 together, this is going to give me Z to the 13th power. Yeah, so when a number is written without an exponent, its exponent is just implied that it's a 1. Now we're switching to dividing. So now I'm going to do 9 to the 7th divided by 9 to the 4th. I'm going to subtract the exponents here. This is the quotient of properties power, which says I subtract the exponents. Okay, so I'm going to subtract them here. 7 minus 4 is 3. So this is going to give me 9 to the 3rd power. Okay. Common mistake here, when dividing powers, don't divide those bases. So don't say that this is going to be 9 divided by 9 is going to be 1. Okay, that's not true. You can see that someone tried to do that here. 2 to the 6th divided by 2 to the 4th is 2 squared. It's not 1 squared. I didn't have you multiply the 2 and 2 to get 4. So I'm not going to have you divide the 9 and 9 to get 1 right there. Okay, we're just going to leave the 9 alone. Okay, example E, h to the 7th divided by h to the 6th. We're going to subtract those exponents and get h to the 1st power, or you can just write h. You don't have to write to the 1st power. Okay, next example, -7 to the 9th divided by -7 to the 3rd is going to be -7 to the 9 minus 3 or 6th power. Make sure you write your -7 in parentheses because we have to write negative bases using parentheses. Now we're switching to the power of a power property, which says I can just multiply those exponents together. Okay, so that's what I'm going to do here. Y squared to the 4th means I'm going to multiply and get y to the 8th power. Think about it, that'd be y squared times y squared times y squared times y squared. There's 8 y's there. Okay, you should not miss one of these because you can literally think it down. You can break it down by thinking about it. W to the 4th to the 5th times the 4 and the 5 together to get w to the 20th power. Think w to the 4th, w to the 4th, w to the 4th, w to the 4th, w to the 4th. There's 20 w's there. Now we have the product power of a product property, which says we can distribute and distribute 5 to the 4th power times y to the 4th power, and we can simplify that. 5 to the 4th power, 5 times 5 times 5 times 5, or use your exponent button, is going to be 625 times y to the 4th power. Okay. I'm not sure which way Big Ideas wants you to write it, so I'm going to write it both ways, and I'll let you figure it out. I'm not sure if that wants the 5 to the 4th y to the 4th, or if it wants 625 y to the 4th. Next one, we're distributing. Ooh, this one's kind of tricky. We're distributing the 3 to the a to the 2nd power. So I guess you could think of it like this. And then we're distributing the 3 to the b. So that's actually going to be, because I have to multiply the 2 and the 3 together, that's actually going to be a to the 6th power, because it's a squared, and a squared. So it's a to the 6th power times b to the 3rd power. And if you're wondering if I can combine that any farther, I absolutely cannot. They are not the same base. So I can't say that's going to be ab to the 9th power. I don't have a property for that. I just have to leave it as a to the 6th times b cubed. Okay, we're going to distribute this 2 there, the 2 there, the 2 there. So that's going to be -1/3 to the 2nd power times n to the 2nd power times n to the 2nd power. I can simplify that first part a little bit. I know that when I have a negative base like that and I'm squaring it, 2 negatives make a positive. Also, 1/3 times 1/3 is 1 squared and 3 squared, which is 1/9. So this is going to be 1/9 positive. M squared n squared. If you're writing that on Big Ideas, please make sure the m squared and the n squared aren't put down there with the 9 as the bottom of the fraction. They need to be actually on the top of the fraction. You could actually write it like this and forget the 1, just write it like that. Or you could write it like this. It does not matter. L. Oh, my timer is going off. Wow. Okay. Well, that's probably a good spot to stop then for today. And we will finish up from example L and on into tomorrow, and then maybe even into Wednesday if we need it. We'll talk about more exponents. We have one more property to talk about, and that's what happens if I've got a negative or 0 exponent. So we'll talk about that, but that's going to be later. Okay, so go ahead and get started. And remember, you're going to get a paper copy of this packet tomorrow. So make sure that you write, even if you don't need a whole lot of work today, you are going to have to write at least your answers down on that packet because that packet's worth so many points. So get started on Big Ideas, and then we can finish our packet up when you guys come back tomorrow. Okay, have a great day.